So radicals. So we'll be starting right off with radicals. And what are radicals? Well, radicals are basically these little guys here, which exist on their own. They can exist on their own, like this hydrogen ion. I'm sure everybody heard about them. The nitrate ion, the nitrite, ammonia. So these are technically ions that exist on their own. Chemists discovered them like that. They existed spontaneously. So let's just give a couple of other ones. This is sulfate, sulfite. Oops, sulfate is 3, sulfite. Oops, discovered as a carbonate 2 plus. Here we have PO4 2 plus, and we have PO4. I think actually this is 4 plus. Yeah, 3 plus. So that's the radicals. The non-radicals: hydroxide ion, nitrate, nitrite, ammonia, sulfate, sulfite, carbonate, phosphate, and phosphite. And again, they're just ions that exist on their own. So now that we know about that, let's get to it. Let's get to the acids. Last episode we're talking about ions and their naming. Now we'll talk about acids. So these radicals are speaking about them because they are also used in making acids. All of them are ions. I see that a lot of them are positive ions, which means none of them are positive or negative, and they can react with a hydrogen proton to give us an acid. They can accept hydrogen protons to give us an acid, which is important because we will need that. Most of chemistry is dealing with acids and stuffs. So for Chemistrian of acids, the normal radicals, for example sulfates, which is the normal state of sulfur and oxygen in the radical form, we'll get a hydrogen. We get actually 2 hydrogen ions. Remember, hydrogen is having 2 electrons in its outermost shell, which means no, hydrogen is not having 2. Hydrogen is having 1 electron in its outermost shell, which means I can actually gain an electron to become minus, or you can lose both electrons and get positive. So that's why basically in some textbooks you see hydrogen not in group 1 but hanging, or they write that the hydrogen is in either group 1 or group 7, because hydrogen is just hanging there. He can either do this or do that. That's the exception in the periodic table. Every law, every rule always has an exception. So he can actually get in the duplet state by gaining an electron, or he can lose both electrons and still get in his own state. So these two react to give us a special kind of acids. Well, it's not special about this, just that this acid itself has so much uses. But yeah, so this name here is sulfate. This guy's name is sulfate, and this guy is hydrogen ion, but a hydride. Okay, remember the last tutorial we explained this, where when we have an ion, we just replace a suffix with "ite," which tells us there is an anion. Now, for naming radicals, for naming acids, if the ion of the acid is ending in 8, conventionally, the rule of Chemistrian, remember the language of chemistry says that this will be sulfuric acid. So this is like basically sulfate or like sulfur, but now which replaced by ic. So it's a rule which will not fail you. Whenever you see this thing H2SO4, you know that hydrogen is the proton, and then we have the sulfate, which is now the other ion, and this ion is called sulfate. So anyone ending in 8, the acids will be ic. Let's take a couple of others. Another example of it, let's look at it. We have nitrate, NO3 minus. plus hydrogen. So hydrogen will give us H and O3. So nitrate giving us nitric acid. So again, anything having it finishes with ic. That's the general rule, just stuck in your heads. 8 as ion gives us ic as acid. So any acid you see having like a radical which you know from these radicals, if you know this radical, you know that, well, hey, this is hydrogen proton, and the ion that will be left will be for this example nitrate, then you know that this will be nitric. Let's take another one. Phosphate is PO4 4 plus hydrogen, giving us H4 PO4. So this here is phosphate. So pretty much I'm sure you know about this. This is phosphoric acid. So remember again, when it ends with H, you just replace the suffix H by ic. Or when you get this acid and you don't know the name, just remember the hydrogen proton will be given out, since an acid will be left with this ion PO4. We know that PO4 is phosphate, and therefore its acid is phosphoric.